The National Electrical Code (NEC) is updated regularly, and understanding the current requirements is crucial for electrical installations. Focusing on the specific case of a 200 amp service in an outbuilding, it's important to address the placement of the service disconnect according to the 2020 NEC. The question at hand involves an installation where the service runs down the side of the building to a meter base through 23 feet of 2-inch rigid non-metallic conduit, and then enters the building wall directly into the back of a 200 amp service panel. The electrical inspector is requiring a 200 amp disconnect at the meter base, leading to questions about the code's clarity and potential changes since 2002. To address this, we need to examine the relevant sections of the 2020 NEC, particularly section 230.70a. This section outlines the location requirements for service disconnecting means. The 2020 NEC states the disconnecting means shall be installed at a readily accessible location either outside of a building or structure or inside nearest the point of entrance of the service entrance conductors into the building or structure. This wording is critical. The key phrase is nearest the point of entrance. In the described scenario, the meter base is the nearest point of entrance for the service entrance conductors. Therefore, according to the 2020 NEC, the inspector is not being unreasonable in requiring the 200 amp disconnect at the meter base. The code provides two acceptable locations for the service disconnect, either outside or inside the building. However, the inside location is qualified by the phrase nearest the point of entrance. Since the meter base is physically the closest point where the service conductors enter the building, the disconnect must be located there to comply with the code. It is important to note that earlier editions of the NEC might have had slightly different wording, which could lead to confusion. However, the 2020 NEC is quite specific on this matter. The fact that other electricians have expressed differing opinions highlights a common issue. The interpretation of the NEC can sometimes be subjective. However, in this particular case, the language in the 2020 NEC is relatively clear and supports the inspector's requirement. When working with electrical installations, it is always advisable to consult the latest edition of the NEC and to verify interpretations with the local authority having jurisdiction, OJ, which in this case is the electrical inspector. To further clarify why the inspector's requirement is justified, let's consider the purpose of a service disconnect. The service disconnect is intended to provide a means of cutting off all power to the building in case of an emergency or for maintenance purposes. It needs to be readily accessible to firefighters, electrical workers, and other authorized personnel. Placing the disconnect at the meter base ensures that the entire building can be energized quickly and safely. If the disconnect were located inside the building, further downstream from the point of entry, a portion of the service conductors would remain energized even after the disconnect is opened. This could create a hazardous situation, especially in the event of a fire or other electrical fault. The code aims to minimize such risks by requiring the disconnect to be as close as possible to the service entrance. In the specific scenario described, the 23 feet of conduit running from the meter base to the service panel inside the building represents a potential hazard if the disconnect were located inside. If there were a fault in this section of the service conductors, it would be impossible to energize them without first disconnecting the power at the utility transformer, which is not a practical solution in most cases. By placing the disconnect at the meter base, the entire run of service conductors is protected, and the building can be safely energized. Moreover, consider the practical aspects of maintenance and troubleshooting. If an electrician needs to work on the service panel inside the building, having the disconnect at the meter base allows them to safely cut off power to the entire panel without having to enter the building. This is particularly important if the building is occupied or if access is restricted for any reason. The location of the disconnect also affects the type of overcurrent protection required. According to the NEC, service conductors must be protected against overcurrent. This protection is typically provided by a circuit breaker or fuses located at the service disconnect. If the disconnect is located at the meter base, the overcurrent protection is also located there, providing immediate protection for the service conductors. If the disconnect were located inside the building, A separate set of overcurrent devices would be required at the service entrance to protect the conductors between the meter base and the disconnect. This would add unnecessary complexity and cost to the installation. In addition to the NEC requirements, local regulations and utility company policies may also influence the placement of the service disconnect. Some utility companies require the disconnect to be located at the meter base to facilitate meter reading and maintenance. Local regulations may also impose specific requirements based on the type of building, occupancy, or other factors. It is essential to consult with the local utility company and the authority having jurisdiction to ensure that the installation complies with all applicable requirements. In summary, the inspector's requirement for a 200 amp disconnect at the meter base in the described scenario is consistent with the 2020 NEC, specifically section 230.70 AON. The code requires the disconnect to be located either outside or inside the building, but the inside location must be nearest the point of entrance for the service entrance conductors. In this case, the meter base is the nearest point of entrance, making it the appropriate location for the disconnect. This arrangement ensures the safety of the building occupants, electrical workers, and firefighters by providing a readily accessible means of energizing the entire building in case of an emergency or for maintenance purposes. Furthermore, placing the disconnect at the meter base simplifies overcurrent protection and complies with utility company policies and local regulations. To ensure code compliance and safety, it is always recommended to consult the latest edition of the NEC, verify interpretations with the local authority having jurisdiction, and follow the utility company's requirements. Now let's delve deeper into specific aspects of the NEC that support the requirement for the disconnect of the meter base. Consider Article 230 of the NEC, which covers services. This article provides comprehensive requirements for service conductors, service equipment, and service disconnecting means. Within Article 230, Section 230.70, Title General, outlines the requirements for the location of service disconnecting means. As previously mentioned, subsection 230.70 AON is particularly relevant to the question at hand. However, other subsections of 230.70 provide additional guidance. For example, subsection 230.70 A3 addresses the accessibility of the disconnecting means. It states that the disconnecting means shall be readily accessible. This means that the disconnect must be located in a place where it can be easily reached and operated without requiring the use of tools or climbing over obstacles. Placing the disconnect at the meter base typically ensures that it is readily accessible to authorized personnel. Another important consideration is the type of enclosure used for the service disconnect. The NEC requires the enclosure to be suitable for the environment in which it is installed. If the disconnect is located outdoors at the meter base, the enclosure must be weatherproof and protect the disconnect from rain, snow, and other environmental factors. The enclosure must also be properly grounded to prevent electrical shock hazards. In addition to the general requirements of Article 230, there may be specific requirements that apply to the type of building or occupancy. For example, healthcare facilities, schools, and other critical facilities may have stricter requirements for service disconnects to ensure uninterrupted power supply during emergencies. These requirements are typically outlined in other articles of the NEC, such as Article 517 for healthcare facilities and Article 700 for emergency systems. To ensure full compliance with the NEC, it is essential to consult all applicable articles and sections and to understand how they relate to the specific installation. The NEC is a complex document, and it can be challenging to navigate and interpret. That's why it is always recommended to seek the advice of a qualified electrical contractor or engineer who is familiar with the code and can provide expert guidance. Now let's consider the practical implications of placing the disconnect at the meter base versus inside the building. Firstly, placing the disconnect at the meter base allows the utility company to easily disconnect power to the building for maintenance or repairs on their equipment. This is particularly important if the utility needs to work on the transformer or other equipment that supplies power to the building. Secondly, having the disconnect at the meter base provides a clear demarcation point between the utility's responsibility and the building owner's responsibility. The utility is responsible for the equipment up to the disconnect, while the building owner is responsible for the equipment downstream from the disconnect. This helps to avoid confusion and disputes about who is responsible for maintaining and repairing the electrical system. Thirdly, placing the disconnect at the meter base can simplify the process of adding or modifying the electrical system in the future. If the building owner wants to add a new circuit or upgrade the service panel, they can easily disconnect power to the entire building at the meter base without having to coordinate with the utility company. Finally, consider the cost implications of placing the disconnect at the meter base versus inside the building. While the cost of the disconnect itself may be similar in either location, there may be additional costs associated with running conduit and wiring from the meter base to the disconnect inside the building. There may also be additional labor costs involved in installing the disconnect inside the building, especially if it requires modifications to the existing wiring or structure. In some cases, it may be more cost-effective to place the disconnect at the meter base, especially if it simplifies the installation and reduces the amount of conduit and wiring required. In conclusion, the decision of where to place the service disconnect should be based on a careful consideration of the NEC requirements, local regulations, utility company policies, and practical considerations. While the NEC provides flexibility in allowing the disconnect to be located either outside or inside the building, the overriding principle is that the disconnect must be readily accessible and located as close as possible to the service entrance. In the specific scenario described, the inspector's requirement for a 200 amp disconnect at the meter base is consistent with the NEC and represents a safe and practical solution. Remember to consult with qualified professionals and authorities to ensure that the installation complies with all applicable requirements and provides a safe and reliable electrical system. Now let's address some common misconceptions about service disconnects. Firstly, some people believe that the service disconnect is only required for large commercial or industrial buildings. However, this is not the case. The NEC requires a service disconnect for all buildings and structures, regardless of size or occupancy. The size and type of disconnect may vary depending on the size of the service, but a disconnect is always required. Secondly, some people believe that the service disconnect is only needed for emergency situations. While it is true that the disconnect can be used to de-energize the building in an emergency, it is also used for routine maintenance, repairs, and modifications to the electrical system. The disconnect provides a safe and convenient way to cut off power to the entire building, allowing electrical workers to perform their tasks without the risk of electrical shock. Thirdly, some people believe that the service disconnect is the same as the main breaker in the service panel. While the main breaker can serve as the service disconnect in some cases, it is not always the case. The NEC defines the service disconnect as the device that is used to disconnect all power to the building. In some cases, this may be the main breaker in the service panel, but in other cases, it may be a separate disconnect switch located upstream from the service panel. Finally, some people believe that the location of the service disconnect is entirely up to the discretion of the electrical contractor. While the contractor may have some input into the location of the disconnect, the final decision is ultimately up to the authority having jurisdiction, which is typically the electrical inspector. The inspector is responsible for ensuring that the installation complies with the NEC and other applicable regulations. To avoid misunderstandings and ensure code compliance, it is important to communicate clearly with the electrical inspector and to follow their guidance. Now let's discuss some best practices for installing service disconnects. Firstly, always use a disconnect that is rated for the voltage and amperage of the service. Using an undersized disconnect can create a fire hazard and violate the NEC. Secondly, install the disconnect in a location that is readily accessible and free from obstructions. The disconnect should be easy to reach and operate, even in the dark or in an emergency. Thirdly, properly ground the disconnect enclosure to prevent electrical shock hazards. The grounding conductor should be sized according to the NEC and securely connected to the grounding electrode system. Fourthly, use weatherproof enclosures for disconnects that are located outdoors. The enclosures should protect the disconnect from rain, snow, and other environmental factors. Fifthly, label the disconnect clearly to indicate its purpose. The label should be visible and easy to read, even in low light conditions. Sixthly, inspect the disconnect regularly to ensure that it is in good working condition. Check for signs of damage, corrosion, or overheating. Seventhly, test the disconnect periodically to verify that it is functioning properly. Use a voltmeter to check that the voltage is zero when the disconnect is in the off position. By following these best practices, you can ensure that the service disconnect is installed safely and correctly, and that it will provide reliable protection for the building and its occupants. Now, let's consider some specific scenarios that may affect the location of the service disconnect. Firstly, if the building has multiple tenants or occupancies, the NEC may require separate service disconnects for each tenant or occupancy. This allows each tenant to disconnect power to their own space without affecting other tenants. Secondly, if the building is served by multiple services, each service must have its own disconnect. This prevents the possibility of backfeeding power from one service to another. Thirdly, if the building is located in an area that is subject to frequent power outages, it may be advisable to install a generator or other backup power source. The generator must be connected to the electrical system through a transfer switch, which allows the building to be switched from the utility power to the generator power. The transfer switch must be located near the service disconnect to ensure that the generator can be quickly and safely connected in the event of a power outage. Fourthly, if the building is located in a flood zone, the service disconnect and other electrical equipment must be located above the base flood elevation. This prevents the equipment from being damaged by flooding and reduces the risk of electrical shock hazards. Finally, if the building is located near a source of electromagnetic interference, ME, such as a radio transmitter or a high-voltage power line, it may be necessary to shield the service disconnect and other electrical equipment to prevent interference with electronic devices. These are just a few examples of the many factors that can affect the location of the service disconnect. It is important to carefully consider all of the relevant factors and to consult with qualified professionals to ensure that the installation complies with the NEC and other applicable regulations. By understanding the requirements for service disconnects and following best practices for installation, you can help to ensure the safety and reliability of the electrical system in any building or structure.